Welcome to Medical Imaging VR. The objective of the project is to help students and users to understand magnetic resonance imaging visualization and human physiology in virtual reality. The project objectives are to explore the use of fully immersive virtual reality to visualize, interpret, and interact with multidimensional data in 2D and 3D. We're also trying to understand the opportunities, challenges, and limitations of using immersive technologies in this context, and assessing the usefulness of immersive reality and gamification as a teaching tool for medical imaging and biology. The interpretation of medical images can be an intimidating experience for students. There are a large number of diseases to visualize, and the need to know the locations of areas of interest. This process is made more complicated by the need to interact with and navigate across several possible views, where what they're trying to do is interpret in 2 dimensions where the body is actually 3-dimensional. This means they lose or can lose the 3D spatial relationships between body parts in 2D. In this project, we're trying to use virtual reality to address this and help the students locate the main parts of the body and brain and their relative placement. In terms of education outcomes, the project and project content is broadly aligned to USA grade level 9 to 10 or UK Key Stage 4 higher biology. After completing the course or game, the student should understand the fundamentals of how to read a 3D scan of the head or body, understand the differences between the different views, learn anatomy, brain parts, body parts, and their functions, be able to identify, locate, and navigate key regions of the body or brain and identify interesting features, and then understand the relative locations and spatial relationships between these body or brain parts. In addition to this, the environment is flexible and can also be used by medical students and neuroimaging researchers. In creating the game and application, we used content and material that is broadly aligned to the GCSE curriculum. In terms of features and functional specification, we have implemented 6 main areas in the learn environment. There's an introduction and orientation area, which provides an overview of the environment, functionalities, controls, and general use. We have a view tutorial, which explains different views and plane types. We have an MRI guided tour, which is an interactive tour in 2 dimensions and 3 dimensions, identifying main physical features of the brain, their locations, general relative proximity, and main functions. We have a quick start location, where the user can select specific of the areas of the brain to learn about and navigate to. We also allow the users to upload their own images and scans to view. And then we have a gamified quiz and game area, an assessment area, where the user can test their knowledge and understanding of the subject material. They can also earn achievements through challenges, tutorials, and progress. The view tutorial helps the user to navigate the body using 2D and 3D views. The learning outcomes helps them to understand the difference between axial, sagittal, coordinate views, how and where to use each view type, and its relationship to the 3D physical space. The MRI tour is a guided, interactive, structured, and narrated tour of the body. 55 plus regions were identified, displayed, and localized in axial, sagittal, and coordinate views using crosshairs and ellipsoid. There's corresponding descriptive audio with text. Regions of interest are highlighted in the 3D cube view, which can be rotated, and also shown in the 2D panels above. The learning outcomes for this part of the application are to learn about the anatomy of the head, different parts of the brain, associated body parts and their functions, and how to identify and locate key regions and features of interest with the best view type to use in that context. The Start Scan Explorer uses a library of existing scans to browse through, and these include a range of MRI and CT scans for different parts of the body and head. In addition to this, the user can upload their own data and scans to explore. And again, the learning outcomes here are explore and learn about the anatomy of the body and how to browse, identify, and locate key regions and features of interest. The game quiz and assessment area allows the user to test their knowledge and understanding of the subject material through a fast-paced game and time-critical gamified quiz. There are 15 random questions to answer from 2 question types. In order to answer the questions successfully, the student has to navigate to the physical location to answer the question using the 2D and 3D panels. In order to do this, they need a good understanding of the brain and body anatomy. They need to select the correct view to navigate to in the shortest time possible. And this facilitates strategic choices on the most appropriate view to select and to use to achieve the quickest time. The game mechanics used here are exploration, strategy, planning, time pressure, question and answers, feedback, assessment, competition, rewards, penalties, status, behavior, momentum, and tutorial. For question type 1, they have to identify, locate, navigate to a specific location of the brain using navigation and selection tools provided on the 2D and 3D panels based on the description of that area or its function. When the required area is located, they press the validate button to confirm their choice, and receive feedback. They can then proceed to the next question. Question type 2 is multiple choice, where the description and function of the area is given with 4 possible options and 1 correct answer to choose from. They can explore the scans if needed, and there's hint functionality available. When the quiz is complete, feedback is given on the number of correct answers, the overall score, and the time taken. Each question type has an interactive hint option available. Hints use a graduated color scale, red to green, across the different views. Green is the correct value for that plane, and red indicates that the location is some distance away. If the user uses a hint, they incur a time penalty. And this encourages a sort of hot and cold type of gameplay. At the end of the quiz, and if warranted, achievements are awarded and a place on the leaderboard secured. So in summary, the medical imaging virtual reality project allows the student to understand the relationship between 2D views of the body, which is a 3D object, and the spatial relationship and relative placement between each of the body parts using virtual reality. The game uses a range of game mechanics to encourage engagement and replayability. The learning environments created allow the interaction, manipulation, and navigation through scans across several views in 2 dimensions and 3 dimensions, allowing new multi-dimensional ways to explore the teaching content. The project is an innovative way to use immersive 3D environments with 2D content to engage students and players. The game and application is available for free on the Steam platform and is compatible with a range of virtual reality headsets. And you can see the link below and in the related material. This is the start and orientation area for the project.
Welcome to Medical Imaging VR, a fully immersive learning environment which allows you to view, visualize, browse, and interact with a range of magnetic resonance imaging scans in 2D and 3D, identifying and learning about key regions of the brain and body. The view tutorial will help you understand planes and different view types in MRIs, which includes the coronal, transaxial and sagittal planes. The MRI tour will show you how to read and interpret an MRI scan and will guide you through the brain and related areas, identifying its major parts, their locations and main functions. The Quick Start Locations area allows you to easily and quickly access different scan locations. In the quiz area you can test your knowledge, earn achievements and get your score on the leaderboard. The Start Scan Explorer area allows you to upload and browse your own medical scans. You can come back and replay this introduction at any time.
The view tutorial helps you understand the different view types and planes used in MRI scans and imaging.
The brain is a 3-dimensional structure, and because of this, any location in the brain can be localized on 3 planes, which are the X and Y and Z planes. The brain can be cut on any of these planes, which are called the coronal plane, the transaxial plane and the sagittal plane. The coronal or frontal plane, shown in the middle panel here and highlighted, divides the brain into back and front portions like slices from a loaf of bread. The sagittal or lateral plane, shown here in the left panel, divides the brain into left and right parts like cutting down the middle of a baked potato before you put on the topping. The transaxial, horizontal or transverse plane, shown here in the right panel, is a cross-section of the brain, like slicing a hamburger bun or bagel across the middle. The brain is a three-dimensional structure, and because of this, any location in the brain can be.
The Quick Start Locations is interactive and allows you to easily access and navigate through different parts of the body or head as selected from the menu system shown. When you select a particular area of interest from the menu system, it navigates to that position and location on both the 2D and 3D views. This allows the user to get a sense of the spatial relationships between the 2D and 3D representations.
The frontal lobe is the most anterior part of the brain. The frontal lobe is responsible for higher cognitive functions such as memory, emotions, impulse control, problem solving, social interaction, and motor function. The mastoid is the part of your skull located behind your ear. It's filled with air cells made of bone and looks like a honeycomb. The cerebellum or little brain is a major structure of the hindbrain located near the brainstem. It is responsible for coordinating voluntary movements and other functions including motor skills such as balance, coordination, and posture. There are two middle cerebral arteries, the right middle cerebral artery and the left middle cerebral artery. The right and left middle cerebral arteries are vital blood vessels that branch off from the right and left internal carotid artery and supply specific regions of brain parenchyma.
The Scan Explorer gives you access to existing scans, but also allows the user to upload their own 3D scans. The MRI tour is interactive and teaches you how to locate areas of interest in the head and body and also interpret those areas of interest in two-dimensional and three-dimensional views.
Here is the nose, which houses the nostrils, or nares, which receive and expel air for respiration alongside the mouth.
A red sphere is used to help the user locate the areas of interest and can be turned on and off in the panel.
And down here we can see the tongue. The tongue is a muscular organ in the mouth that manipulates food for mastication and swallowing as part of the digestive process. It is the primary organ of taste.
The user can move between the three-dimensional views of the head or body part and the two-dimensional panels and planes. You can rotate the 3D view as required and see the corresponding 2D views on the panels.
The paranasal sinuses are over here. These sinuses are a group of four paired air-filled spaces that surround the nasal cavity and are located near the eyes.
In the quiz and assessment area, the users can test and assess their understanding of the subject material through a game and gamified quiz. These are time-based, where the objective is to answer all the questions correctly in the shortest time possible to get a high score, earn achievements, and secure a place on the leaderboard.
Locate the cone-shaped neuronal mass responsible for autonomic functions including vomiting and sneezing.
There are 15 questions to answer for each quiz session based on 3 question types randomly selected. To complete the game quiz successfully, the player has to physically locate and navigate to the required areas of the body and brain using the controls on the panels. This is time sensitive, where the player must make strategic choices under time-based pressure using exploration game mechanics to traverse the brain to the answer location in the quickest time possible to earn achievements and a place on the leaderboard. The player can achieve a score or time which indicates their level of expertise and competencies. Positive and negative feedback mechanisms based around the time taken to complete an exercise are included, with time penalties incurred for skipping a question or task. To complete levels, earn achievements, and rank on the leaderboards, the player is required to have a good understanding of the core material and how to read magnetic resonance imaging scans, and also locate the different parts
Locate the
of the
most
body
anterior
or
part of the
head
brain.
as required. The application includes instructional scaffolding implemented in the game, where the player can obtain context-specific hints when required or requested, and this reduces overall player frustration and encourages engagement.